then deploy that PMML out to hot live running servers. That's one way to do it. We can take the Spark model and convert it to raw Java code. Okay, cool. Yeah, so live stream's going. Right, like convert that to raw Java code, ship that out, and then compile it on the fly on those servers, and it starts to predict off the new. Riley, can you guys hear me okay? So that's kind of the slick, cool way. There's actually quite a few projects. Well, actually, there's not as many projects as I thought that go from PMML to C++ or to Java. There's a couple smatterings and a couple research projects, but they've only done a couple models, and so yes, I was like sort of not yeah, I was not pleasantly surprised to see the number. Yes, I wish that there was more out there. So that's something in the first quarter of 2017. Our group is actually going to spend a little bit of time. We're a bit hesitant to go directly from a Spark ML model into raw source code. Mainly because Spark changes faster than people can keep up with. The current Spark ML models, the guys that created Spark, which is Databricks, they don't really like PMML, and they tend to change their models quite a bit. So yeah, right, like we'll talk about some of these trade-offs later, but we're probably going to start with PMML and just convert it to C and to Java to do performance tests. So we're pretty performance really sensitive. Our potential customers that we're starting to talk to are really big guys like Cisco and Quora and PagerDuty. Really, anyone know PagerDuty? They're yeah, pretty high performance company. So let's see. Let me start. I actually took this meetup over from someone. Is the actual old owner here somewhere? That ran this meetup. Okay. Yeah, he like abandoned it. Right, I was like, there's like 900 people in this thing. I'm gonna take it over. So let's start off some fun slides here. Give you guys an intro, and then I kind of want to hear about, not really individually, but I kind of want to hear about you guys and what the makeup here is. So yeah, I'm in San Francisco, so I got the U.S. flag. Last time I was here, I was pleasantly surprised when I came back to the U.S. to see who our new president was going to be. Yeah, of course, I was keeping a very close eye on things, but yeah, we're fucked. Just gonna be honest, we're totally fucked. And yeah, I found a picture of Margaret Thatcher. I guess, yes, obviously that's not the new prime minister, but really new person is very similar to her. So there's a funny hat. I couldn't remember her name, and yeah, but yeah, Thatcher was very like Googleable. So yeah, how do you guys feel about Brexit? Fucked? Do you feel the same way? Until Trump, yeah, you guys were like super happy about this. I don't know what happens. I have friends in those swing states, like Missouri and Ohio and Iowa. And I was just like, what's going on? Anyway, yeah, like enough about Trump. Let's pretend like things are fine. Yes, I wish I could really have Obama for 8 more years. That'd be kind of fun, right? Yeah, that'd be nice. Maybe, like Michelle Obama was always kind of talked about, but she was not going to run, I guess. All right, so thank you, Rise. Thank you, Barclays. Thank you, PipelineIO. It's a great space. I'm curious to see the new space. So I started this meetup in San Francisco. Since then, kind of expanded globally. Spoke in lots of different countries. What's cool about that is I get to meet a lot of different people and hear lots of different use cases. And what I've come to realize, this is actually one of the reasons I formed this company, PipelineIO, is we're all struggling with the same thing. And there's a few companies like Netflix and Uber that are building this sort of deployment pipeline, right, like after the training pipeline ends. But it's all very specific to their environment. They don't really have an interest in sort of open sourcing this stuff. There's also, what I've come to realize is that, right, like the whole infrastructure really gets in the way quite a bit here. So yeah, I was talking to you about Kubernetes earlier. Once Kubernetes came along and things like Docker for Mac came along, this is really very significant. So Docker you were able to run this on a Mac before, but it was janky and you had a VirtualBox and the networking would be all jacked up. The same thing with Windows. So just this summer, like Docker for Mac native, and I believe Windows is like native also, right? Or do they still kind of create? Yes, any Windows users here? Okay, good. So yeah, this stuff has become, and there's this project Minikube, right? Yeah, so do you guys use Minikube, where you can essentially create on your laptop like a smaller version of a production cluster? So this is huge. This sort of solves that problem of like the data scientists having one environment locally with their own Python libraries, and then wanting to have those same Python libraries extend out to production, which was always different, or it was always difficult because those two environments were different, right? I mean, small versions with like matplotlib, for example, would just screw things up. So, okay. So let's start. We'll just kind of talk about the meetup a little bit, do some Spark updates. When I was here last time, I was on my way to Brussels for the Spark Summit. I just want to give you guys, Bradley did it? Spark Summit? Yeah. Did you? Cool. Yeah, it was definitely one of the better ones. It was less Databricksy and more really everything else, which is good. I'll give some TensorFlow update. Actually, when I went back to the States briefly, I went to TensorFlow training, which I'm going to share with you guys the slides, which I probably shouldn't, but they're public and you could stumble upon them on your own. I'm just going to make it easier for you guys to stumble upon them. It was the first TensorFlow training I had been to where they go beyond just the fucking MNIST, right? Where it's like more, they show right, like how to build your own operator, how to just more complex, more of like the innards of and right, like how to actually take TensorFlow and like use it within your own environments, right? Because you're not always right, trying to classify digits and postal, right? Like we don't all have like postcode right, like use cases. And then of course at the end here, we'll talk about like deploying these things from a live Jupyter. All right, so real quick before I ask you guys just briefly about you, this is me. Someone created this like emoji. One of my groupie fans in San Francisco sent this. It's pretty funny because it's almost, they changed this logo with something else. They put a Cubs logo there. It's kind of funny. Right, like do you guys know anything about right, like American baseball? Cubs first time, first World Series in 108 years. Yep. So yeah, that was everything that was happening out here. So I was fucked on the president's side, and then I got fucked because I couldn't go to any of the World Series games. So I was double fucked. But yes, I found you guys, and that's. So yeah, I mean, just real quick, like I assume what there's like financial people here. You guys just kind of give a hand. Yeah, and so by financial, I assume it's banks and insurance and yeah. What am I missing? Those are the two I worked with in Chicago. So. Got it. Okay, cool. And then do you guys have any media companies around here? Yeah. So yeah. There's tons of ad tech around here, right? There's tons of ad tech everywhere, I guess, right? What's your current infrastructure? Yeah. Wait, what's that? Oh, really? Sweet. Yeah. Cool. Jupyter. Yeah. What other? Yeah. Yeah. How about Kafka? You guys use Kafka? Or... Yeah. Sure. So how about you guys? Yeah, these guys crashed the. Look, people. Yeah, they helped me get all mic'd up here. I apologize. I'm trying to get this to the direction I'm actually facing, talking to you. Yeah. So any other domains I'm missing? Any other significant ones? You guys okay? You're in the white shirt back there. Yeah. What do you do? You do what? Consulting. Okay. Like primarily, what kind of domains do you do? should have just left well enough alone here. But yeah, the live stream people are like, stop it. Okay. All right, and then I assume people here are here to see TensorFlow, and you have experience with Spark as well. You guys have any experience with Spark? Yeah, a little bit. Okay. Oh yeah, the reason I created the advanced Spark meetup and then we tacked on TensorFlow last year, or I think the beginning of this year. Even in the Bay Area, there was Spark meetups, big ones, by Databricks and like some of, but they started turning into just marketing and promotions and things like that, which was driving me nuts because as a person trying to learn Spark, like 2 or 3 years ago, like I wanted technical depth. I wanted someone to show me code to actually get in. So formed it. And, yeah, basically all demos, typically very few slides. This is the first one I'm doing here, so I'm going to use a couple more just to kind of tell you guys about me and hopefully you come back. I also did a workshop here last month. I think there's some people here, right? Yeah, you were there. Where we covered this thing I kind of jokingly created. It's called the pancake stack, where it's got, I don't think there's a slide on it, but it's pretty much everything. It's like Presto and Airflow and NiFi and Cassandra and all this stuff. So, and it's a big acronym, and I've got pancake-stack.com you can go to. But it's a workshop. It's a full day. We cover, we basically build an end-to-end recommendation engine using Spark and Spark streaming and Cassandra. And so I've since changed it a bit, and now using Kubernetes for everything. Before it was one big Docker, it was just a huge monolith, and everything was configured to be localhost. And but once people came out of the workshop, they wanted to use it, and scaling out one big gigantic Docker image is not the way to go. But the goal here is to sort of cut out the engineer or the, I guess, maybe machine learning engineer, but that's not really the best way to put it. But the goal is so that data scientists can actually push things out into production on their own, which freaks people out, right? This totally freaks people out. This is something I got comfortable with at Netflix. I was there for 2 years, where we had tons of power, right? They're kind of known for freedom and responsibility. And ops groups hate when developers can push things out. This, like most companies. But I joined Netflix, and then yes, all of a sudden I'm looking at system stats and looking at my load and doing instrumentation and just tons of charts and yeah. So when I would push a build out, we had to go in and actually do the monitoring ourselves and then do rollback. That's only available if there's good tooling, right? Yeah. So Netflix has this super badass tooling team that can really keep up with our needs and stuff. So that's sort of what we're doing. We're trying not to be like a DevOps tooling company, but that's what everyone struggles with is the infrastructure. But yes, I'll show some screenshots here that should hopefully make it a little bit better. So yeah, globally we have about 10,000 members. San Francisco makes up half of those because that's where it started. Here's the repo. This is the one we use for the training. Actually, I just added a link in here for the second generation, which is the one that's Kubernetes based. But this is pretty much what all of the demos, not just for the workshop, but for all of these meetups we use here. So it's gotten quite a bit of stars and for things just in the last few months even. Our deliverables as a research company are Docker images, soon to be Helm charts, right, which is a Kubernetes concept where you sort of deploy multiple Docker images and they're all configured together. Yeah, so Helm is sort of, it's kind of like a package manager. It's sort of like RPM, but it's at sort of the application layer. And it's supported by Google First Class. It's actually off of the Kubernetes, I think it's Kubernetes/Helm or something off of their GitHub. And you can actually commit these Helm charts in there and you get feedback on them. They try to get people that are doing the same thing, like if there's a MySQL Helm, then they say, no, just use that one. And, so it's quite a bit of deduping. Okay, so the Spark update, Spark Summit, there was a couple, so there's this concept structured streaming. Yeah, this is all the rage now where you can actually run SQL on your Kafka streams. So this kind of works. It's not, it was supposed to work with Spark 2.0, which just came out maybe a month ago or a month or two ago, but it doesn't really work. I think that will get better with 2.1, but they're really trying to compete with Flink and, you know, like Kafka streams and some of these more full-featured streaming engines. Yeah, that support sort of per record, right? Like event-based, where you then so you can do complex triggers and things like that when like an event comes in. So that's what I think a lot of 2017 will be for the Databricks and the Spark community. Let's see. Yeah, then doing like machine learning. So structured streaming just means SQL pretty much, but then you can do like machine learning actually on these streams. So one of the things that we cover in the workshop, let me go back here real quick. So this is a live site. This is HTML, which I just give to you guys because I don't want you to be writing HTML. That's the easy part. But actually talk to Kafka. We're like rating, I think actors and actresses that you rate in like whatever way. There's this kind of slow path where you store the data and then have a data scientist go in and run models and push the model. And then there's the fast, cool path where we seed the model with what was generated offline from like the night before, but then throughout the day, actually capturing this data, right, like using Spark streaming and making small little changes to the matrix factorization, right? Those two factor matrices, item factors and the like user factors, so user and the item from like your guys' perspective. So yeah, these get updated throughout the day so that we're actually capturing real time and it's continuously deploying, right, like a new model. So for the workshop, you just do every 5 seconds because it's small data. Yeah, so this is pretty much how right, like Netflix and some of these other guys do it, but they do it every hour or every 4 hours, right? So, but yeah, the ability to sort of capture what's going on throughout the day, and then at the end of the day, these get blown away and it starts from scratch because you don't want to kind of go along that trending path too long because so at like the end of the day, they take a global snapshot and then do the matrix factorization, start from scratch, and then intraday make the changes. But yeah, this is fully automated. So there's no human right, that's in the loop. And actually, once the data scientist creates the initial model, then you can deploy it and just have it run on a cron job, something like that, until they want the new model. There were actually 2 talks. This is the first, second Spark Summit. I think there was 1 talk last summit where they were talking about this whole deployment thing. So yeah, pushing these models out. All right, quick TensorFlow update. This is the slide you want to take a picture of if you're interested. Check out these slides. They're awesome. They were built by Google people directly. Yeah, once again, more than just effing MNIST. Right, like, have you guys seen the not MNIST data set? Like, yeah, specifically not MNIST. These are online, yeah. Oh, sorry, my slides. I'll post them onto the Meetup for sure. Yeah, I actually meant to do that before so you guys could follow along. But and this is the GitHub repo. This is actually referenced inside of here, but if you just want to take a quick gander at the GitHub repo, check that out. Right, like again, these are good reference slides for when you do start more complex stuff with TensorFlow, and right, like need to kind of again start to extend TensorFlow to your specific needs. We actually cover transfer learning, which is pretty huge. So, right, like transfer learning in this neural network, right, like context is where you train or take a pre-trained model, right, like the inception model, which was takes days and days, and this is what like Google gave us this model. They trained on their data set. They learned features about dogs and cats and castles and stupid shit like that. But now what we want to do is use that same model, but now point it towards our domain, right? So maybe family photos you have, which would be kind of a fun little side project. But instead of right, like running your photos through that whole network, and then coming out with cat, dog, whatever, you can actually train it, right, like retrain it, or like transfer that training. That's where the term transfer learning comes. And you only need a small amount of data because those neurons have actually picked up edges and can figure things out. But when you start to train it with your own labels, like this is grandma or grandpa, or this is your old 50s Chevy or whatever, it'll start to learn that. And it just takes a couple hundred, right, like of these images to actually start to really learn things. So that's covered in here. All right, so real quick, worked with some like gaming companies. Riley, do you guys know about Stitch Fix? Has anyone heard of Stitch Fix? Yeah, these guys are badass. They're in San Francisco. The like domain is, well, they started off women's clothing, but they now do men's clothing as well. You ask for, or you sort of fill out kind of your preferences. Your what's interesting is that there's a human that's in the loop. There's a human stylist that they're the ones actually getting the recommendations. If you think of typical collaborative filtering with like Netflix and like Amazon. So it's the stylist that actually sees the full list. And then from that full list, they send you five pieces of clothing based on sort of their knowledge and what's going on right now and the market that they're, right? Like they have stylists in all the hot markets. Yeah, I don't know if they're around here actually, but like San Francisco, San Diego, Chicago, like all these cities. So that's one interesting thing they do. They also, when you return clothes, you have to fill out like a form on why you don't like the clothes, and it's things like it was too short, or the V-neck it was too deep, or something, or so they start to apply sentiment analysis and like natural processing, things like that, on your comments to sort of learn things about you that way. And then thirdly, they actually use neural networks. Yes, I always forget. I think the slide might come up later. They take sort of the popular, so they train a model on some of the popular clothes, and then they pipe in some of the non-popular clothes, for example, and out comes a slightly different version of the unpopular clothes that now makes it popular. That's the thing. Right? They can then feed those pictures. I mean, it's physically images. They can feed those images back to the supplier of the clothes, who can now start to make little changes to the clothes. Maybe the stripes go vertical instead of horizontal. Yeah, so like whatever comes out of that, which is pretty interesting. Yeah, so Stitch Fix, I've got quite a few friends now that work there. I think they have about 70 research engineer, or like research scientists. They're like one of those companies that people feel they've kind of grown a little bit too much in the machine learning space relative to the rest of the company. But people that are there are super happy because they're doing the exact thing they want. But if you're looking to move to San Francisco and wanting to change jobs, that's definitely a good place to go. So when I started, I took these slides. I was using Zeppelin quite a bit. Again, I'm like a Scala Java guy more than Python, but this is one way actually. So this slide, I built a text classifier, so decision classifier in Spark, in Scala, and then the output. So there's this method, you can't really see it. It's called toDebugString on your model, and this actually prints out what that like tree looks like, right? I mean, it's got the if statements. It's just split points and things like that. So that's actually this is still within Spark, or this is a Spark debug. So yeah, jumping out the tree. So as part of the code generation, some of the stuff I'll like touch on later, we can grab that same model, and it's basically follow the same code that's printing this out. We just build like Java source code. It's just a bunch of things, right? And then generate source code and then push that out to the live running server. Yeah, so model deploying, model scaling, and serving. Yes, like I said, Kubernetes really helped out here. online model training, that's the sort of real-time model training I was showing as trends commit, make small changes to the weights. And then model optimization, so this is the like basic code generation, right? Like taking trees, flattening them in certain areas. Yeah, some of these trees that we're seeing out of Cisco for they're like anomaly detection, fraud detection, and they're like 20,000 levels deep. They're trying to get sub 5 like millisecond, and they can't do it right now with Java, and so they're wanting to go to C. Yeah, so the goal is to be able to just kind of push out. One sort of interesting thing, we actually haven't built this yet, but so once you right, like click this button or right, like run this script or whatever from the notebook, it should return you a link that has dashboards for the data scientists to not just see system metrics, which they may or may not really be interested in, but also right, like predictive metric. So picture pushing out what's called a canary of the new model. So it's the same runtime, so like they're pretty confident that right, like heap isn't going to blow up, and load should be pretty much the same, whatever. But now they have this right, like one canary with a slightly different model that they want to test, and that's running right, like alongside 1,000 prediction servers or classification servers that are already. That's kind of the current, and then comparing it to the new one, and just right, like showing metrics, right, like relative to the key here is to be able to shadow traffic, sort of splice it off to the canary, and then just, so log the result, and then just sort of dev null things after that. But yeah, so the actual prediction comes back from the current cluster, so that really users aren't affected. But yeah, so sort of internally, like you can compare what the current cluster, that current model is predicting versus really the new model. So people get pretty excited when I talk about that. Yeah, I'm going to cover this in a little bit. This is model serving. Right, like, do you guys use Hystrix for the circuit breakers? Yeah, so I'll show. Oh, do you use Spinnaker? Yeah. Yeah, totally. Yeah, Spinnaker is the next generation. It like used to be called Guard, and it was before. Yeah, so Amazon still doesn't really have very good tooling around their cloud. So Netflix being right, like completely dedicated to the Amazon. So yeah, so they're the ones that run the Amazon stuff, and then Google's supposed to be doing Kubernetes, but I don't know, they're kind of slacking. But it's the ability to basically have one tool that you can control Azure, Google Cloud, and so there's teams within Microsoft building the Azure version, and you can have this sort of hybrid cloud control panel. But yes, I assume that like you're using Amazon specifically, yeah, which is going to be the one that's most supported and the most active because of Netflix. Right? Let's see. Yeah, so continuous training, same as online training. We're focused on Kafka, Spark Streaming, Spark ML. I should have TensorFlow on here too. Yeah, this is what I was talking about, right? Like throughout the day, we're going to make changes to these weights here and here, so that when we do new predictions, when we do the dot product, it's going to capture intraday results. And then here's the other one. So before we were just updating the PMML, but now, so this is the actual, this is taking that same output here and then converting it into a Java class. So this is decision tree underscore generated, same split points. Then, yeah, so the goal is to compare the like PMML version, which is sort of an interpreted version, because you give it the like PMML descriptor, you give it the input data, and then it has to run through each time, whereas this is a little bit more native. All right. Yeah, so focus is 2017 is going to be performance and CPU generation. We've got a GPU CUDA guy. Right? Like, has anyone done any CUDA programming? like low level C, it's totally barbaric. It's like, it's worse than when you do Scala and then look at Java code. It's like look, it's horrible. It's just like, all right. Okay, we only hire nice people. All right, so there's going to be 3 demos I'm going to show. We're switching into like demo mode. One of them is going to be this concept of a circuit breaker. Do you guys know what this like application pattern is? It's by Michael Nygaard, I think is the guy that coined the term. And the thinking here is so at like Netflix, for example, we had what was called edge services. So like there were multiple edge services that talked directly to the devices. And those edge services were essentially facades and some, like a bit of enrichment to talk to these other services, right? And so our edge service, which was the streaming edge service, talked to about 50 other. And that was everything from like device security to like predictions, recommendation service, to the search service, like things like that. So we were sort of the main proxy. But what would happen is if one of the internal services ever got like went down, or if it got overloaded and started to take like 50 milliseconds, like 100 milliseconds, 200 milliseconds, then that would back up and basically block all threads on our edge layer. So now one service could essentially take down all of Spark streaming, and we depended on 50 of these. So the chances of not Spark streaming, sorry, Netflix streaming. Yeah, so we were having problems with uptime. So essentially what these circuit breakers do is we put the circuit breaker sort of wrapper, right, like around all of our dependent services. These show up here as these things here. And if there's ever slight like anomalies or things start getting backed up, we can open up the circuit, which is bad, and start to return fallbacks. So when we shifted over to this architectural pattern, we couldn't even like compile our code anymore, like not without implementing get fallback. And that like get fallback method would be as simple as like just going local to the AMI, to the actual EC2 instance itself, and just start to return JSON with the top 100 movies, for example. So not personalized, you're in this degraded state, but the user can still continue to click around, right? And like most users, typically wouldn't really notice that blip. So this really helped uptime. Loved this. There's ways to configure it to say like how long you should wait. The good thing is that when you like open your circuit, now you're letting that dependent service start to recover, right? And like this would usually come into play when we, being the edge service, would start to scale up. This was after the Oscars or some sort of event that was not the normal part of the day. Yeah, because like we all sort of coordinated the auto scaling. But yeah, so we would scale up real quickly and forget to tell the dependent services, right, like the prediction service, that like we were scaling up. And so we're basically doing like an internal DDoS attack on our own server, our own services, which then affected all of the other services within. So not just streaming, but also search and other things like that. Yeah, so these circuits open. It starts to drain traffic onto the dependent service. They can recover, they can scale up. And yeah, we would get them on the phone and say, oh yeah, we forgot to tell you that we just added 5,000 more servers. So, and sometimes we forget to tell Amazon that we're adding 5,000 servers. Yeah. 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 Oh, yeah, for sure. Each of these, yeah. So each of the dependent services was just like another microservice, right? That we depended on. We implemented the sort of streaming business rules, which was sort of our layer, but to figure out which countries they were in and to do geofencing, and because like the studios get real crazy when people in like the UK can watch American movies and things like that. So we started to have to implement, and that was actually one of the first ones that we took down pretty quickly, was the geo service, because that team didn't have a lot of experience yet and scaling out. So yeah, so scaling out, because these are all stateless services pretty much, right? I mean, this is taking in input, doing some processing, and then it's going to return something. So if you just add 5,000 more of these behind the same load balancer, now you have 5,000 more people to listen. And so yeah, so like we would scale up our like microservice because we were getting more and more devices talking to us. So we had probably one load balancer that now had 5,000 more servers to sort of distribute to. Yeah. Oh. Yes. Yeah. Well, that's a good point. I mean, yeah. I mean, if you're doing like a rolling upgrade, something like that, where you are pushing out this new model that might be returning something different. The cool thing about working, right? Yes, I went from banking and the insurance industry in Chicago, where I basically spent my whole life, and moved to San Francisco about 7 years ago, and suddenly I'm now working at like Netflix, and not or how do I put this right? Like approximations and stochastic ideas like start to really surface there, because like you're not counting pennies, like you're not worried about like losing messages if we lost a play event, or a stop event, that wasn't like the end of the world. But yeah, right. Like for the most part, you're giving the same inputs. You might get back some different response, but you would obviously try to. Oh, yeah. So you would try to prevent that, and like the way that we did these like rolling upgrades is we would shift traffic over to the new, and so all the same customer would now go to the new cluster. So from the customer standpoint, that same, it would always be the same response, right? So yeah, we're not, right? Yeah, right. So we're not introducing any sort of like randomness within the customer's experiences. Yeah. But they are operating independently. Yeah, that's the thing. Is like, and ways that they would auto scale up is based on CPU load, right? So suddenly, because basically, like, we don't want someone that has to be there watching these metrics and say, oh, now we need 5,000 more. We would be monitoring like CloudWatch and other monitoring tools that were built by Netflix. We'd be keeping an eye on CPU load, and once the average CPU load across the whole cluster got above, I think we had them set pretty low, so we would auto scale up quickly and then scale down slowly. So I think at 40 or 50% load, like we would just start adding more and more instances. But yeah, I mean, like we're talking thousands here, and each instance would be just a 60 gig RAM, 4 8 core box. So just like commodity, rather easy to instances, because we were very much horizontally scalable, we didn't really rely on the vertical. Yeah, to answer the question. All right. Oh yeah, one thing too that this circuit breaker, this wrapper gives you the ability is you can actually batch up requests. So I'm going to talk about this a tiny bit with the TensorFlow serving blurb, but picture many like matrix multiplications coming in, right? Because I'm trying to figure out here. So this is my users. This is my user vector. This is 0.3 and 0.6 or whatnot. This is the item vector. This is the movie vector, right? These are floats, doubles, whatever. When I want to get the prediction for that user for that video, I just do a dot product. So we don't want to be doing one of these for each each time, because typically we have many users coming in that are asking about many different. So we can actually, I guess, demultiplex or combine these multiple. And so because Hystrix is this wrapper, that's the name of the open source project Hystrix. It's this sort of wrapper. It can actually, instead of doing a bunch of dot products, it can actually combine these into do matrix multiplies. So you would have it every like 20 milliseconds basically. So it's just normal batching. You can increase the throughput, but the response is going to at least be 20 milliseconds. Now you have many responses that then get demultiplexed or whatever back to the original clients. So at the microservice level, it's taking in multiple requests from different callers. And you can do the same with matrix multiplies too, right? If you're doing a bunch of matrix multiplies, you can actually, so TensorFlow does this natively. It will take these sort of smaller matrix multiplies and put them edge to edge, and it knows the offset of here and here, and does one big matrix multiply. This is especially important for unlike GPUs, right, where the sort of transfer costs can tend to dominate the actual calculation, the CPU cost, the compute costs. If you can take one, or yes, just take multiple of these smaller matrices and then build up one big one and have zeros everywhere else, do the big matrix multiply, pull it back, and then you can reconstruct each caller's result, which is pretty sweet. So the other one will push out. I'm going to use Jupyter. This is a version of Zeppelin using Kubernetes. We're definitely using Docker. Docker is like butter now in the Bay Area. Docker and Kafka, pretty much. Yeah, everyone uses it. Let's see. Oh yeah, and then I'll show where we're going to actually generate source code, and then it's a simpler version of this. It's not the tree, but and then push it out. So Spark internally uses this project called Geneva to take your logical plans. This is part of the Catalyst query optimizer. It takes the logical plans for your SQL, for example, and plays with the AST and does the constant folding and does all that fun stuff. And then previous versions of Spark, I think Spark from Spark 1.4 or 1.5 and 1.6. So let's say you do a map, a filter, right? And so that would actually be two separate function calls that were being generated by Geneva. So it's going to take your sort of logical plan, that SQL. It's going to create two separate Java methods. So in Spark 2.0, they actually fuse those two together. So now this is huge because from a JVM standpoint, doing function calls, you have to go up the virtual function chain, and stacks are involved and all kinds of crazy stuff. So being able to sort of collapse at runtime what you're trying to do into physically one method, this is huge. So that's how they're getting sort of 10x type things. It's basically just sort of working with the JVM, figuring out what the JVM's doing, and then try to work around that stuff. So similar to how they did Project Tungsten, it started about a year or two ago, where they're basically bypassing garbage collection within Java itself and just creating super long byte arrays, and just cycling through reusing, and basically doing their own garbage collection. So yeah, any questions before I start the demos? Yeah. Cool. Yeah. Yeah, so we are scaling out. Yeah, people always say scaling up, or scaling up typically means adding more memory, adding more processors on the same machine. We're just going to a better instance or a faster instance. This is all scaling now. Yeah, this is all horizontal. Yeah. Oh, cool. Okay. Yeah, the code. Let me to get around that. I can actually let me upload the PDF here. Quick. Exports. Yes, I'm going to upload this. I'll start the upload now. This will be really quick. Share. Any other questions? Smoking weed. About, I mean, we started this particular like pipeline repo actually started around August of last year. And yeah, how did this go? I think I was actually working, no, actually it was 2 years ago. Yes, I was at like Databricks before. And yeah, one thing about Databricks, they're very focused on Spark. And that's, everything starts with Spark. Even there's this project Tensorflow that you guys might have heard from. It's sort of, right, like what I think it is kind of a far-reaching way to get everyone to, right, like don't forget about Spark. Right? Yeah, we know TensorFlow is there. We know distributed TensorFlow is there. Distributed TensorFlow completely negates the need for Spark. Like, you don't need Spark. You do for, you know, right, like ETL and things like that, of course. But at least to me anyway, like I'm starting to think of Spark as more of just an ETL, and you know, some of the ML stuff is fun and it's easy, and I can't remember what my password is. I switched profiles over to the PipelineIO. Anyway, if you can tell those people, I'm gonna upload it, like literally right after. Kinda. Yeah, one of that one diagram I showed where there was kind of the slow batch, you know, that goes you know, down. That's more of the I mean, that's on purpose. That's because you when you train on, right, like historical data, batch historical data, like that's going to be more accurate than just sort of making small little changes without, you know, global knowledge of like what else is going on. So, because like essentially we're making changes at the batch level, where that mini batch is, you know, either like 5 seconds for the workshop, or it could be an hour. But that's all that the system knows about at that point. So not until each night when it can kind of, but there's, yeah, definitely like that. I didn't think about that actually when I first, because I kind of pushed the Lambda out of my head like a while ago, but that's pretty much what it is, yeah. In terms of training. Yeah. All right. Let's get to some demos, make sure. So this is going to be our fun. So there's, this is going to be where we generate PMML and then push it out. So right now there's no activity. I've got a load test that I'm going to run once we actually push out the model. This is where we're going to generate Java source code and push it out. I actually don't think load test setup. We can set one up real quick. I'm just using JMeter, you know. But okay. So right now there's no activity. Oh, and then something to point out. This was a little bonus for you guys. This is Google. So one side effect, something I didn't realize, and I don't want to make a big deal out of this because like I haven't done, right, like enough sort of control test to make sure that like this is a valid conclusion, right? These are performance benchmarks, which everyone gets kind of nervous about. But one thing you'll see is that Google, for the same instance or similar instance, similar price, right? That's basically what we're all looking at is the price of these instances. Or like actually is it's like literally twice as fast. And I've got separate clusters, so like I'm not running, actually I'm running the load test on like Amazon. So it actually, but actually this is just the amount of time it spends inside of the call and outside, and then when it comes back. So this has nothing to do with the network latency. But the same server, 8-core, 60 gig, which I still haven't inspected actually the physical hardware. I'm sure it's definitely related to that, but it's price that we're worried about. Actually, one thing I was going to extend this was not just the request per second, but the sort of dollar cost or the quid per second or something, right? Quid, yeah. And what you can do then, and like this is totally crazy. This is like totally future Jetsons kind of thing here. Is you can like dynamically. So say you have spot pricing going on within Amazon, and suddenly, I mean, it's still and so so that starts to go up, and now like Google becomes cheaper. So you can actually dynamically shift traffic over. Right? So Kubernetes lets us do this. Still a little bit early for Kubernetes in terms of true hybrid cross-cloud support. With a cloud, they can balance like across the different regions and things like that, which is very powerful. But they're like actively building this, but it's sort of, what's the project? I think it's called Kubernetes. Yeah, that's like Kubernetes is where it's sort of across all clouds, and they're totally cool with it. Like I have no idea why Google would be on with this, but well, actually, I do have an idea. It's because they're so far behind in the cloud race that, and I mean, this is like one thing. If they can win on performance, and people start to see this, and they can very easily shift traffic over using Kubernetes to their clusters with just a config file. This will get people using it. So yeah, we'll see this in a sec. But yeah, to answer your question, it's been about 2 years, and then I left back in June to do this full time. It's like tough getting my friends, like they're still working on the project, but it's not their full-time job, and it's like they want to see, what's the term? Well, yeah, customers, right? Just like anyone wants to see customers, but yeah, we're all kind of having fun because once money comes in and VCs come in and all that stuff, then customers, Jesus, right? Yeah, then it's not fun anymore. So let me just run through this real quick. So, sorry. Yeah. Totally, I know. So let me zoom in here so people can see. But I've got this notebook. There's some, prep here that you wouldn't normally have to do, but I just want to kind of out what's going on. This is like a bunch of scripts I created. This is obviously going to collapse into one. Yeah. Oh, so right, like so just to give context, I used to work at like Netflix, and then I went to Databricks, which is the Spark company, and then the IBM Spark Tech Center was formed, and I hopped on board over there. It was just a couple blocks away from the Databricks office in San Francisco, and built out that team. So that I think we were up to like 60 people when I left. And they have like 4 Spark committers now, which like they had 0 when they started. So they hired a couple. They brought a couple of them up. Spark committers in especially the Bay Area, like you can get a lot of them. So like these guys, they just happen to be in the right place at the right time, or making lots of cash. So yeah, anyway, just pulling down some scripts here, which I'm going to use within the book. This isn't quite a one-click, but I can't figure out how to. There's like the notebook extensions or whatever, you can build pretty things, and I just haven't gotten around to figuring it out. it's a little bit too much UI for me. But okay, so just to give you guys like an idea, there's this sort of training cluster that's living within Amazon. It's kind of I call it training. It's sort of where, oh, actually I can show it to you. This is a tool I actually picked up from the Selden guys that they use for their Kubernetes clusters. It's called Weave Scope from this company Weaveworks that has kind of hopped on the Kubernetes bandwagon quite a bit, and thank God they did, because this is tooling I don't want to build. But this is everything. So here's my Spark master, my Spark worker. I'm going to show with one command we can actually scale from 1 to 10, and it takes seconds. So that's really powerful. That's one thing that the Databricks product does, but like Zeppelin doesn't do it, like a lot of the open source things don't do it. So we solved that problem. Anyone use Presto? Yeah, so Netflix loves Presto. It's more appropriate for the ad hoc sort of intraday analysis. It's a project out of Facebook. They're like heavily starting to build on machine learning to Presto, the Facebook people. So it's starting to look more and more like Spark. But not many people really know about it. Yes, like Netflix loves it. I think Airbnb has this nice UI. But the one big difference between Presto and Spark SQL is if a node dies with your Presto query, that whole query dies. So that's why this is good for sort of intra things where you're babysitting it and watching the query and going to lunch and coming back. If you're going to run like an overnight job that's going to generate millions of recommendations, that's not what you want. You would want Spark, like Spark SQL, because Spark can actually recover within a query and kind of route around it. Whereas Presto just kind of chokes, and then any new queries that come in can like work around it. But and there's ways to script it. You can use tools like Airflow and some of these scheduler workflow tools where if it fails, you just rerun it. But there's probably something systematic going on anyway. So here's the Hystrix stuff. Here's Jupyter. We've got a Hive Metastore there. AirPal, that's the Airbnb Presto UI. Kibana, Airflow, like Elasticsearch, Zookeeper, Sandra, Kafka, Zeppelin. So this is all, with one command, you can get this going. If you go to follow the pipeline repo there. Yeah, I'll post a link after too. You just have to give it your Amazon creds and you're good to go. So this is kind of the master controller. This is where Jupyter's running. This is where Spark. So this is, I've got this running on 1 or 2. Two of the, I think there are 3 2XLs. So yes, each one has 8 cores and DMs. So these are just spread, like wherever Kubernetes felt there was like available resources, that's where these things were created. And like you can pin with Kubernetes, you can say this needs to go to a GPU instance, this needs to go to like a 16 core instance or whatnot. You can, yeah, and that's desirable, yeah, for sure. Because if you don't, it's kind of like Linux processes where the one that's causing the most trouble is going to get shot in the head, the killer. So yeah, I mean Kubernetes, and there's ways to say to sort of prioritize certain like the Spark master, you want that guy to stay up more than with Spark workers. The Spark workers can recover. Spark master, when that thing goes down, you have problems. So yeah, and that's a whole. I mean, yes, I was at the Kubernetes conference in Seattle last weekend. Even the Google guy that like works on this stuff and is part of like looking at Borg, which is the current Google like monstrosity that they've been using for years and years. So like Kubernetes is like the second generation of Borg, but not used internally by Google. So the team that's building the second generation which is Kubernetes, keeps looking at what failed over there. So I think things like priorities actually aren't there yet, but that was one big thing that comes out. Just if there's probably multiple ones that could be killed, choose the one that. Yeah. So yeah, the whole capacity planning thing is tricky, right? And like so many people ask the question, and it's like totally load dependent and like environment dependent and all that stuff. So. But yeah, his whole thing was actually consistent with the way Netflix does capacity planning, which is push out canaries and see how that new build is doing relative to the current build. So basically doing actual, not like back the still like back the envelope, but don't really rely until you actually push it out and have a way to tear it down. Right. And then you can tie those together. Yeah. And it's outside of some, yeah. Yeah, but yeah, and right, like I don't want to answer that question for them. I just want to give them, show for that same input, this was the two different answers, and then let the data scientists tear that down or make the tweaks or whatever they want to do. So. Okay. Yes, all these notebooks are out there. They're on GitHub. I'll post the link. Wait, did I already have this? I'm nervous when I have copies. Okay, so that was the main sort of training, or like cluster, and now there's two more clusters. There's one more cluster, but it's running in both, right, like Amazon and in Google. So it's the same code, the same models. But I'm just going to compare the two. I'm going to split traffic between those two and load this up. So and these are called the prediction clusters. So I'm going to switch over to the prediction cluster. Let's take a look at what's inside of it. So these scripts, yes, I hate magic scripts when people do this, right? Like this, you have no idea what is going on back there. But this is like essentially the kube CTL, right? Like things, just so that I can keep it simple. But this is a pretty easy one, pretty. Pods within Kubernetes are logical, are like containers of Docker containers. So they can contain multiple containers per pod. I think I don't have any. Yes, I keep it at one pod per container per one pod. So, but like you could sort of logically group containers together. People always think, well, maybe Spark Master and Spark Worker should be in the same container, but that's actually not what you want. You want to be able to scale out the workers separate, so the workers are in their own, and then Master's in its own. And that each of those things was a pod, right, that I was showing on that. Which actually, here's the link right here. Yes, I'm going to show, here's Spark Master. This is its own pod. Oh, what's cool about this tool, this weave scope thing, is I can actually select a pod, and because I have one Docker container per pod, I can do this fancy trick here where I could actually go right in. Oh, so actually I can just look at the logs, or I can actually hop right into that Docker container. This like changed my entire life. It's like there's a way to do it with Kubernetes, but it's like this huge long again, I was always screwing it up, but like I can literally find it on that, click right in here, and I could start. I could look at the logs, right? I could do top. I can do whatever on here. But actually, you don't have to do top because it's doing it for me right here. Okay, so that's a cool little side effect I didn't realize. Yeah, you can actually export these views and take a look at the networking. You can look at the actual hosts or nodes. Yeah, so this is, I have 2 EC2 instances being managed, and there's pods and containers kind of split throughout there. Now, pods can get scaled out by what's called in Kubernetes land, they're called replication controllers. I think that's changing to replication set, but it's basically like an ASG within Amazon. So you would tell the replication controller, which is something that we're about to do here, to scale out the Spark workers up to 5. And then, yeah, instantly there's going to be 5 more pods inside of that replication controller. So yeah, these are all just ephemeral. They can come and go. If they die, Kubernetes will see this and will actually spin up a new one to match it. And it's gonna. There's ways to pin things again. Like I said, if this was a GPU instance, I would pin certain GPU workloads there. Or, but for the most part, I've just been kind of Kubernetes figured out. All right, so. I'm going to switch back to the training. So there, I was showing the like the one prediction cluster. Actually, did I switch over? I didn't show. Oh, yeah, I was setting this up like I was going to do everything within Amazon, and then be like, oh, I can also do Google. So yeah, forget I told you about Google. Otherwise, it's going to ruin the surprise. So here, switching back to the training thing, which we just did. Now I'm running this magical script, but what this is doing is kubectl, kubectl, telling the replication controller of the Spark worker to scale out. Yes, I'm not doing a very good job passing in variables to these scripts. Again, I'm kind of just in hack mode right now for this type of stuff, but you would normally be able to specify the number of workers here. It's just hard-coded. So let's. I could show you this actually 2 ways. I could show you directly from the Spark master. Boom. So that was a couple seconds ago, and now there's 5. I just took just the time it took me to babble about some stuff and then pull this up. So I can see it this way, or if I go to WeaveScope, I should be able to see it here. Click replica sets, workspace. What's cool is that you can actually search and filter. So show me all the Spark workers. And there's 5. They're literally pulling from Docker Hub. So I've built the Docker images for this, and these are all available on hub.docker.com, I think. And you can search, if you search, I think, if you just search flux capacitor, pretty much the only. That's. Yeah, I bought the domain name like 20 years ago and haven't had anything to do with it, so I used. Why is this not? So once you build, it's a totally different paradigm probably than what you're used to, with configuration management and having Puppet and Chef and all that crap, right? This is actually I've created, where's Spark Worker? I should be able to there's not too many here. There's 2. Here's Spark Worker. So this, if I click on it, it'll show me when I last pushed it. 7 days ago. I haven't really changed this too much. I'm just writing code now I'm writing Spark apps now. I'm not playing with the infrastructure much anymore. It's going and pulling this, which has been pre-configured. This actually has TensorFlow installed, so you can run tensor frames, right? This has also Anaconda, has NumPy and all those good things. What's cool too is I'm using Jupyter Hub. Yeah, has anyone used Jupyter Hub? It's sort of a multi-tenant way to run Jupyter. So if you just run Jupyter straight up, it's like one process and everyone's on that same process. This, you can have separate spawners. And actually, if you guys try to go to that URL, the jupyter.demo.datasticks.com, That's kind of a little pet name, but I'm like waiting for a nice legal letter from Data Stacks or my old company Databricks. But I'm like a domain name. I just have way too many. But if you go to that URL, you can. So right now it's not locked down. So you can put in your own username and it'll give you your own separate process. So there's different spawners. There's like process spawner. There's Docker container spawner. So for each user, like you can actually spin up a whole separate Docker container that they can then set up their own libraries, and then they can export that container and make that the new standard. So and then the reason I bring that up is because you can actually go to the Jupyter home. Thanks for coming, man. You can, because I'm using Conda's version of Jupyter Hub, which is open source, like you can actually click and look at the extensions, code py, all that stuff. So this is why I really like Jupyter these days. I don't really like Python, but mainly because I'm sort of a JVM guy. But yeah, this is, and like you can install. This is what I was looking for. Is that you can install new Conda packages directly from here. So these are all the available packages, and then these are the ones I currently have installed. So that was the Spark. Oh, and then the other thing is that you can actually go in and select that replication controller and say, scale it down. I could do it from this tool. So drop it down to 2. It's slower on the scale down, which is actually good because you want it to drain and do all kinds of things there. But at some point, some of these workers will end up in a dead state. So here they're alive. But I've essentially started, so replicas, I press down, I think less than 3 times down to 2. So the cluster, the Kubernetes cluster controller is out there taking care of these. Yep, so there's 3 that are dead right now. Oh, and like you could do cool things like Spark-worker greater than 2%. Or wait, what is it? CPU greater than 2%. So you can actually start to filter based on systems stats, which is really cool. All right. Spark, you mean? Oh, I don't know. Totally, yeah. What's the syntax? Yeah, I don't really know. All right. So there we scaled out. So let's build up a Spark session. This is Spark 2.0, so we use Spark session instead of Spark context. We're going to load a data set. This is actually living. I created this bucket called Datapalooza, and I just put some of my sample data sets. This is the somewhat famous and boring census data set. This is what we're trying to do is we're trying to train a decision tree such that when we give it input with sex and occupation, work class, age, it can predict the income. Right. So this is the R code for all the R freaks out there. You say predict income based on all the other features. This is the Spark, PySpark stuff. What we're doing here now, yes, I should spend like a second or 2 on this, is we're building up a pipeline. And this is a fairly new concept to Spark. Came around Spark 1.3, I think, but it better matches scikit-learn and their concept of pipelines and transformers and estimators and evaluators and things like that. So the first version of Spark ML that was ML lib didn't have pipelines, and it sort of had its own goofy, naming like mechanisms that didn't at all match scikit-learn. So there was a lot of pressure from the scikit-learn community, and the Spark community like adopted that. So here we train this model. So now we have this pipeline model, which is not just the decision tree. In fact, so here I'm printing out the decision tree, but it's actually the second stage, right? The like 0th index is the formula. And so if you have this complex pipeline where you're doing normalization, standardization, things like that, which is normal, we're actually able to save the model as the whole pipeline model, or in this case, we're actually going to generate PMML that is the whole model. So now when we go to actually score or really do the predictions, any new data goes through those same transformations. Yes, otherwise you get bad predictions. So that's the tree there. Here's where we actually generate the PMML. This is not a native Spark thing. Like I said, Spark and Databricks do not like PMML. They have something against XML, I think, which is what PMML is based on. I do too, but this really does save quite a bit. There's this project, in case you guys don't know, I'll just mention it quickly, JPMML Spark ML. Actually, just the whole JPMML GitHub organization is pretty cool stuff. So that's what's converting Spark models into PMML. This is full featured. This contains all of the Spark feature transformers, all of the models that are currently in Spark 2.0. So that's the evaluator. That's what we're using on the scoring side, which is those like Netflix open source prediction services. So that's taking the PMML plus the JSON document with the age and the work class and all that, and scoring that. So the guy that created this, he's out of Estonia. He's this project called Open Scoring, which is basically the closest it would be to my stuff would be the those like Netflix microservices. So I'll show some code later. The actual prediction services, but he has ones where you can plop them right in Tomcat or use them with Heroku, and it's essentially doing the evaluation. So he's got one. You can actually from scikit-learn create PMML. From our models, you can create PMML. This is why we really like. I think that's pretty good. Got an XG boost. We like going in terms of code generation. We don't want to build all of, like we don't want to learn or write code specific to scikit-learn, specific to R. If we can get them into PMML, then we can just generate from there. Right? There's a couple products that do code generation right now. There's H2O. Has a way where you can build a model and click on it and say generate Java Pojo. KNIME, K-N-I-M-E. Like if you guys know, it's kind of a visual way to do feature transformations. You can plug in Spark, plug in Hadoop. They have a couple of their model for code generation, but not all of them. There's also, this is my favorite one. I'm surprised it's not up here on the top. There's Keras, K-E-R-A-S, which is a library on top of TensorFlow, and Diana, that if you generate so basically Keras to PMML. So there's a way to take your TensorFlow, because PMML actually does have, it's got support for like neurons and activation functions and things like that. So kind of cool. So here we generate the PMML. Here's where, so this is kind of that step where it's like, now what? So I've got, I built this model. Now what do I do? So here we convert it to PMML. Now there's two options from here. And I've got examples of both where you can take an existing cluster and just push out this new PMML. And then in memory, it'll swap and then now start to predict. That's the mutable like model deployment. which I'm not really a big fan of. It's fun to demo because it's fast, but sort of the better way to do it here would be this here, right? Like the immutable model deployment, where we would essentially save out the model, we would commit it to GitHub. That would trigger a workflow, maybe like an Airflow workflow. I've been looking at like Jenkins, but kind of moved away from that just because it's super full featured. It's just a lot. It just feels a little bit bloated to me. And it would, so kick off this flow that would slurp in that new model from GitHub, build a new Docker image. So now we have one model per Docker image, right? This is really powerful. And now you can deploy that new image out as the canary and then do the comparisons. And you can always tear that thing down, because the second that you start to do mutable things, right? Like now, some of those servers might not have gotten the update, and then you have to have all these sort of checks and balances and say, yeah, did you, please like report to me, did you get the update? But now, if you have the immutable model, and actually tie it back, and like you would version it with the same, you would version in Docker, like you would version that same image with the GitHub version when you committed that new model. So now, like you can tie all these together and say, what version of that Docker image? Okay, I know that that's this, right? Like GitHub hash, and you can tie them back. So, but yeah, just to show you guys the code, here's the. This is the like mutable model. So we're calling the prediction endpoint. This is the one that's at Amazon. We're saying update PMML. That's just a REST service on this. This is Spring Boot, sort of decorated with the Netflix. There's this project called Kubeflix that actually does it. Yeah, so it's using like Kubernetes to do service discovery and things like that, which right now Netflix's stuff all uses their own proprietary discovery mechanism. So the guys from Red Hat actually have this library that you can now use it. That it's basically using the Kubernetes DNS. Okay. And then this would be the like the evaluation. So once we've pushed the new ML, this is the evaluate endpoints, and we're giving it this JSON. This is a post command. We're giving it that JSON. Oh, and then when we actually update the PMML, we tell it that this is XML. And then data is the PMML bytes, which is what we generated right before. All right, and then, so yeah, the evaluation, this is the result, and it's saying the prediction is 95.6% sure that it's less than 50, greater than 50, probability that it is 4.3, or yeah, 4%. So let me just actually push this out in case it. Okay. And here it's just giving me a 200 saying, yes, I got the new model. Everything is cool. So that pushed that out. Let's do this one real quick. Evaluate. All right. Should we do the load test? You guys want to see that? Sure. All right. I just created the script for the load test. Let me see if it actually works. I could do this from the command line. It's not. It is. I was trying to create a magic script to do this, but. So here, zoom in a bit here. What I'm doing is I'm calling kubectl, or some people call it kubectl, some of the crazy Google guys. You say create you give it a file, so that's your Kubernetes descriptor of the replication controller, and basically this is saying which like Docker image should I be pulling in, and then how many replicas. It's going to start off with 1, and then the Docker image knows what command to run when it's started. So in this particular case, it's going to fire off JMeter and just start pounding those 2 endpoints, the Google endpoint and right, like the Amazon prediction endpoint. So all right, so we should see it right here, load test. The manual way to look at the logs, if you don't want to go through Weaveworks, is this is the dynamically generated pod ID called load test. So I told it create a pod inside of a right, like an ASG, basically the scaling right, like replication controller, and it created this pod and then right, like returned it back with this goofy name. So now I can actually say get me the logs of that pod, and this is JMeter running. So quickly go back to the Hystrix thing. Here we'll see these things lining up. So there was something going on here. I was having this bug where it's not showing. It's only showing the thread pool, but it's essentially one-to-one. But yeah. So let me pull up. This is the, which one is this? Amazon. And let me pull up the Google one. Put them side by side. Yes, nice seeing you again. All right, so it's changing a little bit. The thing is that the threads aren't actually showing. Yeah, that one's not. Like this is the good one because this is the one that shows you the requests per second. So anyway, but yeah, so this is both of the clusters here. This is the Amazon one on the left and Google one on the right. So this is Hystrix actually reporting, because this is the wrapper. It knows the times of when that request came in to the processing to what goes back. And if I killed something here, we would start seeing the circuit opening, and then so also I can scale this up. That's one of the other things here. So let me switch up to the prediction server, take a look at this. We have one prediction PMML, so that's the prediction service serving up the PMML. Now I'm gonna, so here's a magic, oh wait, that's doing a scale in. Let me do a scale out. So I'm saying scale out here, which is just, it's the same thing that we did with the Spark worker, but we're doing this on the prediction server inside the prediction cluster, which is separate. This is, if I do a get pod now, I should see, so all 5 of these are running. You can tell Kubernetes to do a health check, because these services actually, because it's Spring Boot and it's like loading in the model and GitHub and everything, these take about 10 seconds to start. So like you would tell Kubernetes to not send traffic for some given amount of time, do 2 or 3 retries, and then consider it dead if it's not up, kind of thing. But so after a bit, we should actually see within Hystrix here. We should see really multiple hosts being registered. Yeah, so actually this number went down. Oh, okay. So yeah, here we see it. Post. Oh, here we go. Yeah, now it's coming up. Something's going on here with these. Yeah, so it's showing you 90th, 99. What I was getting about three, uh, 3 milliseconds for the 90th. No, I was getting, what was I getting? 4, 6, and 6. So 4. Wait, it's the other way. Yeah, I was getting 2, like 4 and 4, and then for the Google, yes, I was getting basically double. Yes. Yes, 1 sec here. Let me, because it seems to like the scaled version better than the. So let me scale out Google real quick. Boom. Boom. Yes. Yeah. That's so. Lower numbers are better. Yeah. Yeah. So I just added 5 more of that same service in Google. So this will take a sec for these to come up. You'll see, yeah, the status there was container creating. That's kind of the initial. Now it's actually loading the service. We can look over here. Should be able to search prediction. Actually, this is the training side of things. I don't think I have weave scope on the prediction side, but because there's only 2 services running. But yeah, let me go back to Hystrix. Okay, so on the top, yeah, so here we go. So these numbers are starting to stabilize. 2 milliseconds, yeah, like 1 millisecond, 8 milliseconds. And this, so that left side is Amazon, the right side is Google. Let me scroll down to Google. And there we go. So this is the 90th percentile are all coming in at millisecond. And then, yeah, as we get into higher ones, this is what I have flipped in my head. 3 and 3. So, and Google, this is still stabilizing because the servers are coming up. Oh, because I actually don't have it set up right now to do that like liveness test, so it's just sending traffic to it like right away. So yeah, these will start to come down, but they'll be about half of what those are. So like 1 and 4 and 4. Right. So I'm doing this exact same request. Yeah, it's just blasting it from, yeah. This is just the scoring, the like prediction side. Yeah. Right. Yep. Exactly. So this is simulating, right? Like I push this out now, and there's devices calling it that we're trying to like classify these things. And it's basically returning. I can't. Oh. And this is from, I mean, this is just like JMeter's command line version or whatever, but it's just saying these are the requests per second. This is what we're reporting as failures, things like that. So what's really cool right now is there's actually, so green is good. Give you guys an idea. Blue is when you start doing fallbacks, right? So yeah, actually one of these actually could, so that one should have returned and been registered in error to like JMeter. These blues would be fallbacks, which is still valid. It's just in a degraded state. Trying to think if I can simulate this. Oh, I can add another load test. So check this out. Or sorry, I can scale out the load test. So I would go kubectl scale replicas equals 2. Replication controller is load test. So this command is telling it to add another. Right now we're at 1, and I'm saying I want 2. So this is going to spin up 2 containers that are now going to be pounding. So we'll probably tip it over maybe at this point. Oh, and then just to point out here, see that number went from 1 to 5. So now this is actually registering, and this is the total throughput for the whole cluster for all 5, and of course each one is usually, here it's a fifth of that. So the load test usually comes up pretty quickly. Yeah, so this one's already started, so we should, let's check out this guy. And there. Side by side. So we should start seeing, oh, yeah, so we're starting to, actually, this typically means is the thread pool. Let's, the thread pool. So this is the thread pool that's involved with that circuit breaker. So when we start seeing purples like that, that's the bad one. That's the one where yeah, we would need to scale it. The problem here is that because I'm using only one for each prediction service, so one in Google, one node in Google, and one node within Amazon is its own. Each one is running just this prediction service, right? Like there's only so many cores. So right now, adding more Docker containers isn't really going to help. We would actually need to, and there's ways within Kubernetes and to actually add more underlying nodes, or really auto scale as well too. So based on CPU load or whatnot. But it's starting to settle in a little bit here. Yes. The idea, yeah, and it's kind of that, it's like, yeah, so if you start using Kubernetes, you're like, oh yeah, this is so cool, I can keep adding more and more Docker containers, but at some point the physical box that you're running on is the limitation. But there's ways to do auto scaling on that to actually add more, like EC2 nodes behind. So once, yeah, because you can, yeah. I mean, just think of them as, yeah. Right. Yeah. Right. So so the question, it's about capacity planning and because the whole goal here is to not think about the underlying hardware, right? And yeah, now that you have to, I know it's something I didn't. Yeah. Yeah, it's super easy to do that. Yeah, I think his version of cluster is the EC2, the physical, right, EC2 cluster, right? And there's definitely ways to do auto scaling right now. They're a bit wonky, I think. Yeah, have you guys gotten auto scaling to work, or do you just open it? Yeah, there's like one or two plugins people have built to do it. Does COP support it? Oops. Ah, yeah, and then tell it to look at CPU load, right, or something, and then it'll trigger off that. So one CPU load hits, about 50%, it'll actually physically add. And then from that point on, when you make a request to add a new container or add more containers or pods or whatever, it'll then start to put them onto other nodes. Right. Just as long as Kubernetes has enough to work with. Yeah. Right, right. Yes, the client has to build in. Yeah. Right, but again, this indicates that our thread pool, our physical hardware, we can try. So the thread pool, surprisingly, for Hystrix is actually set pretty. This is pool size for the whole cluster. This is 10 per worker, or so it's 50 for all 5, because there's 5 of these pods running. These 10 seems kind of small for a thread pool, but the thing is if you start adding, that usually doesn't help. Right? Sometimes you can maybe get a little bit, but this is primarily a problem of you just don't have enough CPU cores to handle this load. So now I physically need more instances, right? So this is what you could trigger auto scaling on possibly. Maybe when these hit a certain threshold, you would auto scale. Yeah, but this is going back to the client. The client sees 500 or whatever, and then we'll ask to retry. But and so what's interesting is that it's not high enough based on how Hystrix is configured here to really open the circuit. If I scale this down, so I've doubled the amount of load going into service. If I go back and scale the prediction services down, you should start seeing some funky stuff here. So let's do it. I think it's under cleanup here. Yeah, so let me switch over to Amazon. Let's look at the number of pods. So right now, so just think of pod as just one Docker container, because that's how I chose to configure it. I really have not yet found a reason to have multiple pods, multiple containers within a pod. So here I'm going to scale in, and I purposely switched it from up and down to out and in because it's more accurate to say in because we're doing horizontal scaling. So here I drop the number, so now these guys get killed. Let's go take a look at our. This is Amazon right here. Yes, Amazon went down to 1. Or wait, what happened here? This guy's still getting traffic, right? I think this is more of a UI thing right now. Is the thread pool getting anything? Oh yeah. Let me just go to 2 because for some reason it's not liking 1. Oh, yeah, and like, do you guys know that you can actually get like there's a terminal within Jupyter? Yeah, anyone use this? This is like hardcore. Jupyter action. Hold on, let me do. I don't actually have to do it from there. I want to talk about TensorFlow serving, because this is more of a the topic of serving these models than the training. I think training gets a lot of like attention already. So let's assume that the model's been trained. There's this project called TensorFlow serving, right? That came out actually day one. Thank you. And TensorFlow serving is a first-class citizen within TensorFlow. In fact, if we go look at the TensorFlow GitHub, let's see it here. TensorFlow serving updated 20 minutes ago. What did they do? They push out a new version. So TensorFlow serving has a few key components. This is the best, or kind of the, all right. So let me just explain this real quick. TensorFlow serving, so these are callers. So this is if you're trying to do classification, something like that, right? You want to pass it like an image, calls in. There's this, sort of Buller dynamic manager. They have this abstracted out into version policy. So version policy is what manages when it sees a second version of the model, right? Like what does it do? Does it keep the existing version going and let it drain? Do they run side by side for some period of time to do to make sure that things are okay? Does it do like a blue-green and just switch over? So there's some stock ones out of the box, which are basically those 2 or 3 that I mentioned. And right now, there's just a file system that you would deal with. You would essentially, when you start up TensorFlow serving, you point it to a like parent directory, and then any new models, you just give it like a greater version, and it will automatically, it's constantly scanning that file system. There's a file system source, but yeah, you can build in like a GitHub source. You can build in like different versions, and when it sees something that has a higher version, it will then promote it, and based on policy, it will do something with that version. One really, really cool thing about TensorFlow serving, and I think I mentioned this at the beginning, is it can do that thing with those matrices coming in. It can batch them up. So when you start up TensorFlow serving, you say, do you want it to run with this batch request functionality? If so, what is the latency? The like minimum latency, like 5, or the batch window size, or batch window time, batch duration, or whatever. It would batch those up and then do all of those calculations and then return back. This is something that we're actually building. So we started to build this, and then I remembered when we started to add Histrix into it, right. So we started to build this for Spark models, this same type of functionality, and then I remembered Histrix is not just a circuit breaker, but also does this like request batching. So that's on our list, is to do that same functionality with Histrix. So TensorFlow serving, I could show a quick demo. Did we see? All right, so Amazon. So we scaled down Amazon to just 2, and now we're seeing tons of these. 16% of these are failing and stuff, right? So I thought it was probably right when I did it. We might have seen some fallbacks, but and then this guy's still running 5, but is only at 8%. Okay. Yeah, so you guys can actually do this at home or on your phones right now, but this is actually from the workshop. This is one of the things we do in the workshop, which is why the URL is a bit different. But so this is just a simple HTML stretching my skills. I was doing a talk up at Zillow up in Seattle. Well, I guess from here it'd be down. So I've given it this URL and I'm telling it to classify it. And it slurps down the image. This is what the image looks like. So Zillow is this real estate company that gives you recommendations on how much to sell your place and all that stuff. Oh no, it died. But yeah, so here it would show the top. I think the top 5 are like microwave, or like dish rack, things like that. So this is how, for things like user-generated content, when you're uploading images to these sites, like they can tell right away if it's been misclassified, or they like don't even have to ask you to classify it, because they can run it through this and they'll say, oh yeah, this is a kitchen. So that's using TensorFlow serving. Let me just try to get that one working, because it actually is cool. Try it one more time, and I can cycle the services. Yeah, right. And then yes, it returns you the like confidence. It's actually, so it's only showing the top 5. Well, this is showing error message, but it's just returning top 5. That's all I requested, but all of the numbers should all add up to 100 or 1, because the final part of the inception model, that model architecture, is softmax, and it's trying to figure out on 1,000 classes, like fit all predictions, fit all probabilities into to like add up to 1, right? And then I'm just showing the top 5, which don't add up to 1, because there's another 1,995 more to go. So is this interesting to you guys? Was this useful? It's a bit more DevOpsy than you're probably expecting, but kind of get you thinking a little bit beyond. Yeah. 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 And it's just so funny because, I mean, I talk to my friends that have moved on from Netflix, and they've gone to Uber, they've gone to Quora, like all these places, and they're all building the exact same thing, which is this extension of the pipeline. It was like when I did a contract for Apple, maybe 3 or 4 years ago. They were like building the exact same thing, like this whole, I mean, the whole pipeline. They're building it from scratch because nothing was there, but and then the ability to like hot swap out models, which TensorFlow serving has. I mean, these are so TensorFlow serving is sort of an interesting project, because you wouldn't have expected Google to release that part of the stack. Like it just kind of came out of nowhere. People were like, yeah, we don't know what to do with this, and it's because most people that you talk to, data science groups, when they're done training, they hand it over the wall, and there's some core like data engineer that has to actually hand type in the new weights or do some kind of goofy. But I mean, people are deploying these models behind just simple Flask web services and things that have no metrics and have no like monitoring around them. And like whenever I ask, so it's like sort of funny because it's like I've chosen to solve a problem that I really like the answer to, but it's like a real problem. But when I talk to data science groups, like they don't really seem to care about this, right? Because it's like this is more right, like DevOpsy or like production-y, and they just want to work on. But yes, I like giving them the tools to see it, and then I think they'll start to dig a little bit. But yeah, giving them the ability to not only spin up a cluster or to like deploy that canary, but also make the final call to say yes, scale this thing out, and tear down the old cluster. Okay, so I have some. Yeah, the transfer learning. Oh, the intraday, the like online training. Yeah, there's some mixed thoughts about that. So specifically, the algorithm. I really want to leave a stack trace up here. It's kind of depressing. The right, like algorithm I'm using that with sort of naturally fits that sort of online. Well, it's actually doesn't. It's sort of a creative way. So sort of online training typically are like linear models, where you can continue to adjust, like predictions and things like that. As you get more data, it's keep shifting the line for your regression. So doing it with collaborative filtering was kind of interesting. The way that we're doing it is, taking those two factor matrices and making, we're using gradient descent so that throughout the day we're just making small changes. Some people have said that, like neural networks, naturally, because neural networks, when you're training them, you're typically dealing with like mini batches, right? Like you're doing mini batch stochastic gradient descent, right? And so you're making changes to your weights based on just the segment of data that you have at that moment, right? Because it's very rare when you can do full, batch, like all of the data all at once to figure out those weights. That's the holy grail, but there isn't for these big data, training situations. It's just not possible. So you do mini batches. So really, if you just kept throwing data at it, and this is something me and my buddy are working on right now, is like the way that you get data into TensorFlow for training is through there's sort of the simple way, which is just it's called like a feed dict. It's kind of like a dictionary, that you just pass in from your program. But like for any serious data, like it's going to come from disk, it's going to come from Avro or Parquet or Kafka. So we're building a Kafka queue. So yeah, queue is the other way. It would be a file system queue where it just keeps getting more and more data, or Kafka queue. The more and more people that we talk to, once the model converges or get, like there's really you're just at risk of like overfitting now. You just keep throwing more and more data. So there's some question as to whether sort of online techniques work. I think it just depends on the type of model that you're training and things like that. But feeding more and more images, might not really help image classification. So, the retraining, transfer learning stuff to me is like pretty interesting. I like that about TensorFlow. TensorFlow distributed is very powerful, right? That's it's going to be model parallelism, or no, sorry, data parallelism, meaning, and so this is true across multiple GPUs on one machine or multiple machines with potentially multiple GPUs. You're sending the same model to each machine. So this is kind of how this is how like tensor frames works, which is that cross section between data frames within Spark and Tensor, and so training within TensorFlow is you install TensorFlow on all of your like worker nodes or Docker containers for here, and you point it. You have Spark load in this huge data set. It's going to partition that data set across the whole Spark cluster, all the workers, and then you say train. You pass it the TensorFlow training function, and on its section of data, it's going to train. Now, there's a couple things you have to worry about, because if your data isn't sort of spread evenly around, like all of the weights are going to be a little bit skewed on one. And then, so yes, after each node trains, it then returns back to the Spark master, which is running the Spark driver for that training job. And then that thing basically acts like a parameter server and merges the weights that have been learned separately, and either average them or add them to come up with the final weight. There's a better parameter server that was presented at the Spark Summit. Right, like, were you at the Spark Summit? Yeah, it's called Glint. There were actually 2 talks on it, which was pretty interesting. And so these parameter servers, that's their entire job, is to allow parallel training. But because this is all approximations anyway, right? And because this is big data and it can't fit on a single node, like there's got to be some way to like communicate between what's been learned and then sort of average it out. But again, this is all stochastic, so one run could, and so, which is where ensembles come in. Right, like the other cool thing is that I've been reading quite a bit about is deep and wide neural networks. Sorry? It's sort of, I think is there a demo on it, but it's where, let's see. Yeah, so like you're actually using a deep neural network for one part, and then using, just like linear regression, and really sort of, so basically creating ensembles, really, so to speak. So it's just like different ways to now start to like combine traditional machine learning with logistic regression. Oh, and then and I'm just throwing shit at you guys randomly now, but look up TF-Learn. This is actually kind of a competitor to Keras. So Google hired the guy that created Keras, and Google internally has this used to be called, what was it called, skFlow or something? It was a way to it was a drop-in, well, sort of drop-in replacement for scikit-learn, but you plug in the TensorFlow version of it. So that way you get access to distributed TensorFlow and all kinds of goodies that TensorFlow gives you. But they changed the name to TF-Learn, which unfortunately there was already another project called TF-Learn. This is Google like inside of their little bubble, not knowing what's going on around the world. They're finally getting better. They're speaking at more conferences and they're starting to get more public. But yeah, check out TF-Learn, but make sure it's the Google one. Like, I don't think it's this one. Yeah, that's right. Because before it was skFlow and it was a contrib project, and then it got rolled into, yeah, you're right. Yeah, so just go straight to the TensorFlow code base, you'll find it. But that does a lot of the sort of low-level details. That was one of the negatives about TensorFlow when it first came out. It was so flexible. It was giving you all the primitives, but people were getting lost in, yeah. So how big is this matrix? Why is this and this thing not multiplying properly? And, why are my dimensions not matching? Things like that. So with TF-Learn, you just kind of declaratively tell it what you want to do. I don't think TF-Learn supports convolutions or something. There was like something like pretty normal that I was surprised TF-Learn didn't support. But, sorry. Oh, Pretty Tensor. Yeah. I've never used it. There's a really good video series I found on YouTube. It's this guy out of Warsaw. It's on my. Sorry. Yes. HVASS Labs. Yeah, he's all about Pretty Tensor. Thanks for coming, man. Yeah, so thanks for the comments and questions. Thank you. Oh, really? Nice. Is it? But yeah, who actually supports Pretty Tensor? Is it him? Is it his project? Is it? it's so hard to tell now, like what. And then of course, you guys have seen Playground, I assume. This is really good for kind of visualizing. Oh, and then just real quick before we do this, there's TensorBoard. So two of my favorite sort of side projects are TensorFlow serving, obviously, and then TensorBoard. So TensorBoard, you would instrument your code, your training code. So as you're training, like you can actually see it within right, these books. You can choose to print out, certain values, right? So here, this is cross-entropy. So this is the loss function. Show me the mean loss function as the number of steps going along here. So this is what you're actually trying to keep an eye on when this reaches a certain thing. And then also, like, you could run multiple models at the same, or run train rather multiple models at the same time. Yeah, my buddy and I got this working in sort of a hacky way, but we have Kafka coming in, and there's two consumers, and yes, each one has its own learning rate. There's different hyperparameters for these neural network, right, like training steps here. So you could change learning rate, which is basically the size of the step gradient descent. And you can plot them both by basically plopping the results into the same, or the summaries into the same directory. And TensorBoard can actually read these, and my buddy got it so that it shows with different colors and everything. And like you'll see one kind of struggling, and then you can kill that one, right? So you don't have to train on that one anymore because this one's dominating. So things like that. The other trick I got from the Google guys at the TensorFlow training is batch normalization. Does anyone use that? Yeah, I don't understand how people don't use that. After I like learned what it was, I was like, wait a minute. So every batch of data? Yeah, I mean. Right. Yes, every batch of data that comes in, because this is stochastic, where yes, each batch then first gets normalized along the activation function or something, and it gets shifted, so that it's matching. If it's like a sigmoid or 10H, it's going to get shifted, right, like standardized, or right, so it's normalized, so that you don't end up with those wildly. Yeah. So again, I don't understand how that isn't always done. But. Yeah, every batch has to have its own, like validation and With for specifically for TensorFlow, or that other. Yeah. Yeah, because if you get kind of wild spikes, like that could throw off everything for the rest of the day. Not really. I mean, for this streaming case, we've been. I mean, so yes, I guess beyond like splitting things up into. At some point, what we've thought about basically is if things like start to diverge a little bit more than they should, just basically stop it, right? Or somehow notify, have alerts on these things so that they're not getting wildly out there. Yeah, exactly. Yeah, there's a lot of challenges, and not many people in terms of TensorFlow are exploring, at least from like what I've heard, are exploring it. All the Google guys I've talked to just say, yeah, no one is doing that. Like it's not, it just doesn't make sense. Sometimes you do want to capture those trends. Sometimes you kind of want to squash those trends. But yeah, there's some really cool tutorials. There's things like how do you do linear regression with TensorFlow, how do you do like logistic regression, and they're super simple demos. But like they really teach you kind of what's going on, and focuses on the activation functions and certain things like that. Kind of the like fundamentals of neural networks. Yeah, that's probably enough, I think, for, oh my God, it's almost 9:30. Oh, and then do you know what, so I mentioned Kubernetes and TensorFlow. These are two Google projects, open source projects. And like a lot of people have been asking, why is Google starting to do this? What's the benefit, right? So I think we all agree that Google's kind of behind in the cloud race, the cloud services race. They just released Cloud ML, the like machine learning. I think it's a full GA release now, or is it still beta or something? They just did something recently where you can call in, and so people kept asking, well, right, like why do I need to use your Cloud ML service when I can just spin up my own, like use PipelineIO or whatever, right? And their answer is that the models that they have released to the public are nowhere near the sophistication of like the actual trained models, like the Inception model that I was trying to use for this thing. The other thing, Cloud ML can do hyperparameter optimization, so it'll do all the different grid searches and random searches to figure out the hyperparameters, the different combinations of hyperparameters. It's supposed to do all that stuff for you. So yeah, like there's a few value adds there, but and then GPUs. What's the interesting thing with GPUs I learned? Yes, obviously, the bus between CPU and GPU is slow, relative to between GPUs. So like, you want to minimize that. But like TensorFlow serving does that for you for the most part. I'm starting to see people using GPUs more on the inference side, or yeah, so more than they used to on the inference side. They still use GPUs more heavily on the training side, but on the scoring, inference, prediction side, I'm starting to see more and more GPUs. Google, the best I could get out of those guys is that GPUs are coming by middle of next year. And they wouldn't confirm if it was going to be those tensor processing units. Like, I don't think it can be just the TPUs because people have so many just normal, right, like NVIDIA, right, like GPU needs, right? Like they've written a lot of CUDA code and stuff like that. So yes, I have a feeling that they don't want to release GPUs first and then introduce TPUs. They want to release them both at the same time and let people choose or whatever. But yeah, GPUs, yeah, CUDA code is it's just horrible. All right, I think that's it. Oh wait, I didn't show. Let me just show Playground here real quick. This is a cool. So what we're doing classification, learning rate 0.03. I'm just starting with something. This is the size of the step as we're doing gradient descent. The goal here is to classify this. We have a bunch of dots in the blue and a bunch of dots in orange. Yeah, I just keep talking, right? Sorry. And then we're trying to find a function that can essentially right, like represent this circle that separates it. So classification. So what I like to do when I show this tool is get rid of everything and just kind of slowly. So hidden layers, we're just going to have. Actually, if we just have no hidden layers, kind of crazy, but. So I'm going to hit run. This is kind of the starting point. There's a bunch of we're trying to find a function that's a circle. Now, the inputs can only differentiate between vertical axis and horizontal, so that's significant. If we start this, oh, and then in the upper right, it's going to show us the cross entropy or the loss function, which I don't know what the loss function is here, but it might tell us. All right, so there, it just has no way of doing it. Actually, it's kind of weird. Yeah, let me add at least one hidden layer. So I'm adding one hidden layer with one node isn't really doing much. So you see it's trying its hardest to create this circle, but it can only do so much here, right? The best it can do with a this and a that is give us kind of one edge, or one side of this circle that we're trying to build. So let's add a second one. Let's see what happens. So here it can, start to separate along those lines. So like this particular edge and this node, or that neuron has learned that particular edge. This is the amount of influence. Okay, so still isn't converging, still isn't. It's getting close though. So let's add one more. Yeah. So do you guys think it'll be able to represent it? Think so? Should they? That just looks like a really poor initialization. Oh, okay. So now it flipped. Okay. Hopefully it did. If we do 4. Yeah, so 4 comes in nice and quick, but that looks like it eventually learned it. So you can play with the activation function. For example, you could do linear. Basically has no chance. Because like the whole point here is you're trying to introduce nonlinearity so that you can start to learn things, and if you're just going to give it a linear activation function, you're just back to square one. Like there's no point even having. So yeah. This one's kind of fun too. It's the swirl. Change the. Let's try really. Yeah, basically, there's no way until we. I think we actually have to add hidden layers here. So this is the thickness is the amount of influence that it has on that particular neuron. It's trying so hard. So have you guys seen this before? Yeah, it's pretty fun. Because you can kind of see where you would want to add layers versus adding neurons. This one, I mean, it's not really. It's just kind of like it's sort of empirical, going through and figuring these things out. Can show one last thing: the inception. I think this might be version 2, but so these are not neurons, because there's like thousands of neurons, but these are the actual layers. So this is 1, 2, 3, 5, 8, 9, and yeah. So resolutions, right? Like you initialize it and basically do like matrix map the pixels. And trying to learn it, and then you would do pooling, so which is kind of that concept of taking what's been learned and then right, like either averaging it or taking a max, something like that. Dropout, introducing randomness as dropout, or sort of dropping out things and right, like letting the network kind of work around around it. But yeah, you always want to drop out only on training and not during the inference scoring side. So yeah, what you do with the transfer learning is sort of snippet here. You don't do, or I guess, but here you wouldn't do the actual classifications. Like you wouldn't actually. What you want is the numeric values, not that it's like a dish or a microwave. You just want the numbers to come out, and then when you retrain it, it's going to learn that those numbers now relate to grandma or the car, your first car. I just wanted to hear you guys clapping. So, yeah, that's all. Yeah, one more thing. Just kidding. Thanks for coming. Yeah, I came to that meetup. I just happened to be here a couple weeks ago, or like a month ago, and came to the one here. It was specifically Tensorflow, so it was the Seldom guys talking about the deployment, and then some other dude. So yeah, wanted to fire it up, and it's always nice to start with a base of people, rather than just. So yeah, I'll be back for sure. Yeah, totally. If you guys have venues, I mean, can you contact me through the meetup and tell me like where? Because that's my biggest problem is like the only reason I knew this place is because there was already a meetup here. So, thanks, man. Yeah, thanks for coming. Yeah, or if your company has space, they want to, it's good recruiting too, right? Get your name. Yeah, but yeah, we could definitely. There's off of in the GitHub, but if you just go to demo.PipelineIO, this is the. No wait, no, that's not. It's going to be kind of. Actually, just go to. Thank you, sweet man. Yeah, nice seeing you again. Cheers. Yeah, there's a bunch of like TensorFlow demos and the FluxCapacitor GitHub one in there. Like there's ones, actually those ones that are in the slides, yeah, that's a pretty good place to start. Like the first day, the second day was the really complex day. Yeah, I haven't really heard too much about that, honestly. I know, I think the problem has been, it's run by the O'Reilly Media people, right? Is it, like that's the same one? Yeah. Because Databricks kind of had one, but then, and I don't think that they have a good look on it, specifically for the certification. And yeah, I don't think they've kept up data frames, data sets, and all that. Which one? The Learning Spark one? Oh my god, man, that's on Spark 1.1 or 1.0. Oh, they updated it? Yeah. Yeah, I know really well. Yeah. Oh wait, yeah. Are you talking about the high performance? Yeah. Yeah, just sort of. For sure. Yeah, what's funny is she's a big fan of like RDDs. She's like, screw data frames, man. She's like, well, the thinking is, if you, if you know really how to write good RDD code, it's basically like, it's like writing bytecode. If you know how to write good bytecode, just like so I mean, I don't really agree with that. But yeah, she's